All right, two graph questions here. Number 24, you're looking for the choice where the parent function y equals the absolute value of x has been reflected over the x-axis. So if it's been reflected over the x-axis, we know that there is a negative in the front of the function, that the coefficient in the front is negative. So that means it cannot be c and it cannot be d. The negative is in the wrong spot. So it's between a and b. We also want it to be shifted right 2. If it's shifted right 2, we should have x minus 2 on the inside of the absolute value symbol, which between a and b is b. Now for 25, you're given a graph and we want to know which of these equations represents the graph. You can do this a couple of different ways. If you want to, you can put it in Desmos, graph each one of these equations, see which one matches this one. That would be the long way. Or you could realize that this cube root function has been shifted. That new middle point is at 1, -2, which means it went right 1 and down 2. If you remember, the original shape of the parent function for the cube root looks like this. So it's in the same orientation direction. It hasn't been reflected. So really the only thing that's been done that's truly important is the shift right and the shift down. So if it went right 1, we should have x minus 1 inside the cube root. So that means it cannot be c, it cannot be d. If it went down 2, we should have minus 2 on the outside, which could be A or B, but notice B has a negative in the front, and we said before, if this is the original orientation of the parent function, which is the same as this new function that's been shifted, there has not been a reflection. So it cannot be B. For that reason, it is A. You're finding the inverse when your function is written in terms of x and y. Remember, you flip the x and y first, and then you solve for y. Since this is an exponential, we know that we are going to eventually convert it to a log to solve. But let's switch it first. So that gives us x equals 2 times 3 to the y plus 5. Now, in order to convert, we've got to get this exponential by itself. So we have got to move the 2 first. It's being multiplied by the exponential. So we're going to divide by 2. That's going to give me x over 2 equals 3 to the y plus 5. Now we can convert. We're going to start with our base of 3. So the base of my log should be 3. So it's log base 3 of x over 2 equals y plus 5. Remember, the x over 2 travels together. So again, that's log base 3 of x over 2 equals y plus 5. Last step is to solve for y is to move that 5. So we're going to subtract 5 from both sides. Pen's lagging again. So we've got log base 3 of x over 2 minus 5 equals y, which is our inverse. Wherever possible, we want you guys to use technology to save your time, as I stated before. This is one of those examples where technology is going to be your friend. James did solve an exponential equation and found that the solution was x equals -3. Which of the following equations could he have solved? So if the solution is -3, you can do it a couple of ways, but we do want you using Desmos. So the way I did here, which is one of those ways, is you put the left side of the equation as one function, the right side as another. You're looking for where they intersect. Specifically, we're looking for the graph that intersects at x equals -3. So if you can see here where I defined my graphs, I made one graph. This is for A. I made one graph 6 times 2 to the x, which is the left side of the equation. The right side of the equation is a constant. So remember, if it is a constant, you cannot just put 3 over 4. You have to say y equals 3 over 4, so it graphs that horizontal line so you can see the intersection. If you just do 3 over 4, it is not going to do anything. And it's not going to help you find the intersection point. So lucky for you, when you graph A, it does intersect at -3. This is where those two sides intersect. That has a x value of -3. So right away we can say that James solved the first option. You could have done the other ones as well, but you should see that they do not cross at, they do not intersect at x equals -3. We've got another technology question here. You're given the equation for a log function and you're asked about its end behavior. You really need to graph this in Desmos so you can visualize the end behavior. So here's the graph of log base 2 of x minus 5 plus 2 for you. All right, remember log functions have a vertical asymptote. So this one is flattening out vertically at x equals 5. Automatically, I can cross out D and C because D and C says that there's a horizontal asymptote. Logs never have horizontal asymptotes. So it's not C or D, it's between A and B. So let's take a look at our end behavior doing the right side first. So as my x's are increasing, so as x's go to positive infinity, so I'm going to the right. In this case, my y's are going up. All right, my y's are approaching positive infinity on the right hand side. Well, lucky for us, if you look at the very first, if you look at between A and B, both of them have the correct vertical asymptote, so that's not where the difference is going to be. Where they start to differ is what their right side end behavior is. We want our right side end behavior to be going towards positive infinity, which is going to be choice B. I don't even have to worry about the left side end behavior because already we can figure it out by looking at that right side. In this question, you're given an exponential function. You're asked which of the statements below is true. It could be one, it could be two, it could be all of them. You've got to figure it out. So best thing to do here is sort of take a look at what your choices are. You've got two that have to do with the solution, solving for x. You have two that look like you're doing the change of base formula, and you have two that looks like you're converting it to a log function. So why don't we do all three of those things and see what we can get. So if I'm starting with 2 times 5 to the x equals 50. All right, that's not one of the choices, but I do know that I can divide both sides by 2 to get rid of that coefficient in the front. So that gives me 5 to the x equals 25. That is still not a choice, but I can see here that x has to be 2 because 5 squared is 25. So this tells me that x must be 2. All right. Well, then it's not this one because x is not 5. It is, however, 4. So we've got one of them and we've taken away one of them. Now let's look at the two where you are converting to be what looks to be into a log from an exponential. So if we take this and we convert it to a log, we're going to start with the base of 5, go towards the equal sign. So it's log base 5 of 25 equals x. Again, that's log base 5 of 25 equals x. That is a choice. That is 3. It is not 5. The base and what you're taking the log of are in the wrong spots. Now, we can continue with what we did here and do the change of base formula. If you do the change of base formula on the left-hand side, you get that log of 25 divided by log of 5 gives you x, and that allows us to choose our final option, which would be 6 and not 2. All right, population of rabbits in an area grows quickly at a rate of 7.8%, so that's 0.078 written as a decimal, according to the model given. In part A, we want to know if there are 13 rabbits currently on the property, so that's our initial value of rabbits, our p sub 0. How many rabbits will be on the property in 8 years? So 8 is our t. We're looking for, in this case, p. So p is going to equal p sub 0, our initial population, which is 13, times e to the 2 times our rate, which is 0.078, times time, which was 8 years. Again, you're just putting this one is just plug and chugs. You're plugging into the formula. Just make sure you're doing your formula correctly in the calculator, putting those parentheses where they should go. And if you do that in your calculator correctly, you're actually going to get 45.3, but remember you cannot have decimal rabbits. So we're going to round down, because if we round up, t would actually be something other than 8. So we are going to round down in this case to 45 rabbits. Now on the second part, we want to just take that equation that we're given and rewrite it in terms of t. So basically we are solving for t. So we're starting with our population equals our initial population times e to the 2rt. We're just solving for t. So again, everything needs to move except for t. We are going to have to convert to a natural log to drop that exponent down. First thing I'm going to do is divide both sides by our initial population. Now I'm at p over p sub 0 equals e to the 2rt. All right, now our exponential is by itself. We convert it to a natural log. I know it's going to be a natural log because this base is the natural base of e. So starting with my base, I'm going to have natural log base e of p over p sub 0 equals 2rt. So again, that's natural log. I'm going to put the e here even though we'll never see it, just so you can see where this went in the conversion. So again, it's natural log base e of p over p sub 0 equals 2rt. And then we're just solving for t, so last step is to divide both sides by 2r. So we can say that t is equal to the natural log, I'm going to go ahead and drop that e now, of p over p sub 0 all over 2r. Similar problem here. Jane gets a new job. She'll be moving soon. Lucky for her, the housing market is doing well and can be modeled by the equation t equals log base 1.15 of 12,000 times the value of her home after 2 years. What would be the equation if she wanted to know the value of her home after a certain number of years? So basically, if you look at all your choices, you're solving for v. Very much like the problem we did for number 30. So we're starting with t equals log base 1.15 times 12,000, or of 12,000 times the value. We're solving for value. The log is already by itself, so we can go ahead and convert. So we're starting with a base of 1.15 going towards the equal sign. 1.15 raised to the t equals 12,000 times the value. So again, that's 1.15. Oh, there goes my pen again. 1.15 raised to the t equals 12,000 v. All right, last step to solve for v is to divide both sides by 12,000. All right, and that's going to give me finally that v is equal to 1.15 raised to the t all over 12,000, which is c. All right, back to the calculator. We are given two dot plots. We want to compare their means and their standard deviations. One is relative to the average amount of exercise versus the average amount of time spent playing video games. We want to know which of these statements is true. Both of them relate the mean and the standard deviation. So we're going to go ahead and calculate those for each of these dot plots. Remember, this is where you go into your calculator. You're going to go to Stat and then Edit. Within Edit, that's where you're going to put the values into your list. You're going to have one list. You can either do it where you have one list that has the numbers for exercise, one with the numbers for video games, and then go through the calculation 2 separate times, or you can just re-edit the first list once you're ready to do the data for the video games. All right, now just audit. To start this off, once you get to where you're editing the list, the most important part is that you understand how to put it in. Each of these dots represents a value. So if you count the number of dots, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You've got 14 dots, which represent 14 different samples. You should have the same number of dots in each case. So you've got ones for the exercise. You've got 1 0. You've got 3 1s. 3 2s, 2 3s, 1 5, 2 7s, 2 12s. So that's what you would put in your list. The dots just basically tell you the frequency. If you put them in the calculator correctly, you should get that the mean for the number of hours of exercise is 4.14. The standard deviation is 3.81. If you do the same thing for the hours playing video games, the mean is 8.79. and the standard deviation is 3.34. Now if you look at these numbers, the mean for the hours of video games is higher, but the standard deviation for exercise is higher, which sort of makes sense even if you don't put in the numbers. If you look at video games, most of the dots are on the higher end, so it would make sense that its mean is that much more than the mean of the hours of exercise. As far as the standard deviation goes, the standard deviation, the values for numbers of exercise are more spread out. They deviate more from the mean. Whereas if you look at video games, there's this one weird value over here, but for the most part, most of the dots are spread around the mean, which means that the standard deviation for exercise is higher. So you really could have answered this question without putting them into your calculator just because of what the distribution looks like. But these are the numbers. And if you look at the statements, it is true that the average amount of hours spent exercising is less than the hours spent playing video games. Exercise was 4.14. Video games was 8.79, but the standard deviation for exercise is higher than the standard deviation for video games, which is also true. All right, last question, guys. You're comparing two different functions. One, g of x, is written in terms of a table. The other one, f of x, is given to you as an equation. Now, I went ahead and graphed that equation because you need to visually see it to answer these questions or pick the correct characteristics. So here is the graph of the negative times the square root of x plus 2 plus 1. And then here's the table for g of x. All right, we're going to choose which of these statements are true. Number one, the range for both f of x and g of x is all real numbers. Well, first of all, the graph is easier to read. Let's look at the graph first. This is a square root function. Square root functions have that endpoint and then have the arrow on the other end. The range and the domain for any square root function is constricted or constrained because of that endpoint. In this case, if we're talking about the range, look at a horizontal line. All my graph is below that point. That point is at -2, 1. So in this case, all of my y's are less than or equal to 1, which is not what this is saying here. It's saying that f of x is all real numbers, which is not true, so we don't even have to worry about the range of g of x for this possibility. So it's not 1. 2, the domain for f of x is is greater than or equal to -2, and the domain for g of x is x is greater than or equal to 0. So let's look at the graph first, which is f of x. I'm going to erase this really quick so I can start fresh. All right, it's saying here for choice number 2 that the domain is x is greater than or equal to -2. Here's -2. All my graph is to the right of that, so my x's are greater than or equal to -2. So that part is right. So let's look at the second part. The domain for g of x is greater than or equal to 0. Well, here are my x's. My first x is -8, not 0. So if we're actually looking at the table, which is increasing once I start at 8. If we're just looking at the values in the table, we would say that x is greater than or equal to -8, if this is the only points of the function, which we know are not. But it does include negative values, so this statement is not true. So it's not statement 2. Let's look at 3. The end behavior for f of x is, as x is increasing, my y's are going down. So let's look at that. So as I increase, as my x's increase, as I go right, my y's are going down. That is true. All right, so far so good. And the end behavior for g of x is that as x is decreasing, so as I go left, my function is going down. So let's see, let's go left on the table. On the y's, as I go left, my y's are going down. That's true. Let's look at the last part. As I go right on the table, my y's are going up. So let's go in the opposite direction. As I go right, my y's are going up. That is also true. So 3 does work. Now look at your choices. The only one that has 2 options is A, 1, and 3, but we already said 1 does not work, so it's not A. So by default, it is B, because 2 was not a possibility either. But let's look at 4 just so you can see why. In behavior for f of x is as, again, we're on the graph. As I go left, my x's are decreasing, my y's are going up. to infinity. That is positive because as I go left, they are going up, but they stop here, can't go any further. That has a y value of 1. So this right here should have been 1. So by default, the rest of it is incorrect. So the only true statement in this case is statement number 3.